All right, so I'm Kyle Fiala,
I'm Luke Vinanik.
and this is a demonstration and description of our LED Cube digital electronics project. So to start, we have a design description.
So for our design, we have our power, which is a 9-volt battery, which is connected to a switch, which is also connected to a regulator, which is a 5 voltage regulator. That is then connected to our PIC, chip, our PIC 18F4550. All the code is on the chip, which is connected to all of our 64 LEDs. They are connected to the anodes. We have 20 outputs. 16 are for the anodes of the LEDs, and 4 are for the cathode of the LEDs. The outputs for the cathodes are connected to transistors, and those are which are connected to ground, which is for the full loop.
So like Luke was saying, we have a 4x4x4 cube, and each column is a common anode shared between the 4 LEDs in that column. And then each layer, all of the cathodes of the LEDs on that layer are shared. So like Luke was saying, the 20 outputs, 16 of them go to the 16 columns, the anodes, and then 4 of them go to the layers, which are connected with these leads. You can kind of see that lead from the top layer going down, and then the lead from the third layer going down, and the second and the first. And then our circuit is on the bottom.
So we have our 9 voltage power supply, which is connected to our switch, which is connected to our 5 voltage regulator, which is connected to both sides of the power. Because the chip is so big, it has 40 pins, so it has 2 power and 2 ground. And then on the PIC, we have all the code, which is connected to each port. And then when each port is connected to a resistor, which is connected to the series of LEDs. So when we turn the port on, it goes to the resistor, which goes to the strand of LEDs. And then we have to turn on the ports with the cathodes, which are the ones with the transistors. And then when that transistor on, when power is flowing through that transistor, it turns on the ground for that layer. So if we were to turn this cathode on and this anode on and this cathode on for this layer, this LED would be the only one on.
We're going to give a quick demonstration. So you can see it's just going through each individual light, which would be turning on one anode and then whatever layer that LED is on, the common cathode. This is an example of multiplexing, which is cycling through each layer quickly to give the impression that the LED cube is fully lit. And that's our LED cube.